Hi everyone, welcome to lesson 4 today for our exponents and logs unit. Today's lesson is working with logarithms. So what is a logarithm? It's basically the inverse of an exponential function. So if you had an exponential function, to inverse it means you're going to switch around your x's and y's. So that's what this was here, was you have an original equation of y equals c of x. If you take the inverse of it, it's going to become x equals c of y. And basically, you just isolate for y to get this equation here, log base c of x. Um, just a quick note here, it says common logarithms have a base of 10, so if there's no number here, if there's no c value by default, it's going to be 10. So if it's log x, that's really log 10 of x. So in number 1 here, it says convert the following from exponential to logarithmic form. So I'm just going to follow my equation here. So if I had this here for my equation, if I want to change it over here, my y value is going to be switched around with my x value, so I should do my inverse first. So I have 2 to the exponent 8 equals 3, which doesn't really work out. So the way that we're going to write that is now 3, because that's my y value, 3 equals log base 2 of 8. And there we go. That makes it a bit more sense. So here the first step is to inverse and then rewrite. So we're going to inverse and then rewrite that. So in this example here, example B here, so what do we have? Right away, so I know my base is going to be 3. If 4 is my exponent here, that's now going to be my answer. So just like over here, 3 was my exponent, so now that's my answer. So I'm just skipping this inverse step here. So I'm just speeding things up a bit. So I'm going to have 4 equals log base 3 of 81. In example C here, again, I have my exponent there, so I'm going to start off with my exponent. So I got negative 6 equals log base 2 of 1 over 64. And for example, D here, it's all variables, so how do we rewrite this? This is now, if that's my exponent, it's going to be B equals log base A of C, and I always put that variable in brackets there usually. In example E here, again, just dealing with more variables, but that's no problem. So the very first thing I want to do, I got to get rid of that too, because in none of these previous questions have we had a number in front of our exponent there. So I'm going to get rid of that. So the very first thing I do is I'm going to rewrite that as a divided by 2 is equal to 10y. And now I'm going to change that into logarithmic. So that's going to be y equals log base 10 of a divided by 2. Over here, again, same idea. We're going to get rid of that b in front of this c exponent d. So I have a over b now is equal to c exponent d. And again, I'm going to rewrite that into logs. So I got d equals log base c of a divided by b in brackets there. And last but not least, here we want to get rid of that 500. So we're going to go 600 divided by 500, which is 1,200 left over, is equal to 2t to the 80 there. That's fine. And let's rewrite that. So that's t over 80 is now equal to log base 2 of 1,200. And of course, if we ever needed to isolate for t here, you're just going to multiply out that 80. So if I ever needed to move on to isolate t, it's just going to be t equals 80 multiplied by log base 2 of 1,200. There we go. And this is just in case you ever needed to isolate for t. In example 2, we're just going to do the opposite. We're going to convert all these logs into exponential. So in example 2 here, if I had an answer of negative 2, again, that's always going to be my exponent, so I need to know my base here. My base is not given, so by default our base is going to be 10. So we have a base 10 to the exponent of negative 2 is equal to, right here, that's our answer, 0.01. On this side here, my base is given, it's 2. my 3y, my answer is going to be my exponent. So I got 2 exponent 3y equals x plus 1. And in that case, we're good there. Over here, I want to get rid of this 2 first again, because all of these questions just had log by themselves, no coefficient. So I'm going to get rid of that 2 first by dividing both sides by 2. So I have 3 equals log base b of 8. And so I'm going to rewrite that. So I got base b of 3 is equal to 2. And if you, or sorry, is equal to 8 there. Sorry, it's equal to 8. B should be 2 because 2 cubed will get you to 8, that is. And so that's why I wrote 2. But it should be 8. And then over here, even though you have a decimal, that's totally fine. Let's start off with our base. Our base is 1.05 to the exponent of n is going to equal to 2. There we go. On the next side here, we have special cases, and so you have 4 special cases that you can work through. So this first one says log c of 1, whatever your base is with your 1 there in brackets, usually right beside, your answer is always going to be 0. This, by the way, is the same thing as saying, if you can remember it, this is the same thing as saying c, your base to exponent 0, is equal to 1, and of course that's the exponential of this log there. Here this is saying log base c of cx is equal to x, and so here, if you really truly think about it, this one is saying if you had c exponent x, that's equal to c exponent x. So really x is equal to x if you had to solve for x there. So x is equal to x there. This one here, c of c equals 1. So again, in exponential, if you ever needed it, it's c exponent 1 is equal to c, and that we know is true. Anything exponent 1 is this itself. So these are always going back and forth between each other as well. And the last one here, this one's a bit tricky here. This one is saying if you had an exponent to a logarithmic equation with the same base, so your base is the same in there, your answer is just going to be x there. It's going to be whatever that after that log is. So that one there is a special case that we can work with. So down here it says evaluate the following logarithms. So you have log base 4 of 64. This I'm going to convert back into exponential if I needed it. So you could say something along the lines of base 4 to what exponent is going to equal to 64. And in this case, 64 I could change to base 4. So this is 4 to the x equals 4 cubed. And again, if I have the common bases, I can remove my bases. So x is equal to 4. And so my answer overall should be just 4. If we have our graphing calculator, we can definitely check this on our graphing calculator. So just pulling up my graphing calculator here, I could just type this all in just to show you what it's going to look like. We know the answer here is 4 because we solved it algebraically. Here on my graphing calculator, I'm looking for the math button. And in this very first column, just scroll up until you get to log base. That's what I want. Hit enter, and you just fill in your numbers. So we have 4 for our base, 64 right here in brackets. The answer here, of course, 3. And I wrote 4 by mistake, but that should have been a 3 there. There we go. Over here, this is log base 10 of 10,000. So again, to evaluate, you're just trying to find what x is, or you could just use your graphing calculator. In this case here, your log button's right here. Without any base, by default, it's 10. So I have 10,000 right here. It's just going to be 4, so our answer here, just 4. Over here, if I want to do it, let's switch back to the long-handed way. If I want to find out what this answer here is long-handed, I'd be 3 to the exponent of x, because this is equal to blank right now. We don't know what it's equal to truly, so it's 3 exponent x equals 81. Well, 81 is the same thing as saying 3 exponent x equals 3 to the exponent 4. So here x is going to equal 4, and of course if we solve that on our graphing calculator, on our graphing calculator we had 3 to the 81, and we should get 4. There we go. Down here we're just gonna speed things up a little bit here. Again, this is the exact same question, but instead we have 1 over 81, so this is now going to be -4 if you typed it in on your calculator, or x equals -4 if you solved it long-handed. Here I'm going to solve this one long-handed just to give you an example. We have base 4 to the exponent x is equal to the square root of 16. And of course the square root of 16 we know is just 4. So this is 4 to the x equals 4. 4x mod 1 that is, so x has to equal 1. So if I typed this into my calculator, I'm expecting to see an answer of 1. So again, we have 4 here, square root 16 goes underneath, and I'm looking for 1 for an answer, and there we go, we have 1 for an answer. Over here, this is just going to be base 2 to the x is equal to 32 under that radical. Let's rewrite that in terms of base 2. So I got, base 2x equals 32 is the same thing as saying 2 to the exponent 5, and that radical I'm going to get rid of by going by divided by 2. So here x has to equal 5 halves, and if you type that in on your graphing calculator, you'll get something along the lines of 5 halves. In this next following, we're just going to evaluate the following again. So this time, if you see any special cases, you can definitely use it. I see log 7 equals 1 here, so this one here is our very first log rule. This one here has to be 0. Why? For this one here, this is the same thing as saying 7 exponent x equals 1. The only thing x has to be 0 to get you to 1, so x has to equal 0 there for this condition to be true. So we know our answer should be 0 here. On this one here, it's the exact same thing. So anything log base of 1 has to always equal to 0. And again, same rule applies. The y would be 1/3 exponent x equals 1. Here, 6 and 6, so x has to equal, and again, this is a special case. It's our third special case, so this one here has to be 1. And again, the idea here, why is it 1? This is saying 6 exponent x has to equal 6. Well, that exponent there on this 6 is a 1, so x has to equal 1, and so that's our y. That's how we got there. Down here, we got log base 5 of 5 exponent 3, that is. Our answer here will just be 3. And again, why? Because we had a special case that says log 5 of 5x is equal to x, or this is the same thing as saying 5 exponent x equals 5 exponent 3, and of course x is going to equal 3 in this case if you switch it back to exponential. Over here, this one here is just going to equal to 32, and this is that fourth special case at the top on your right hand side there. You have base 2 to the exponent of log base 2, 32, so x here is 32, so our answer is going to be 32. Down here in F, it's the exact same thing, base with a common log base here to 10,000, our answer should just be 10,000 there. In example 5, this says evaluate the following by the change of base identity. So this here was back when we were working with TI-83s and you did not have proper functions on your calculator. This says if you wanted to change your base, you're going to do log A, which is base 10, A divided by log base 10 of C, and then you'd get the same answer. So here for number 5 should be pretty quick. I'm just going to use my graphing calculator, so I'm going to show you it in 2 ways. The first way is to use what we have on our graphing calculator, so I'm going to use log base. So we have log base 4 of 1024. Answer should be 5. And here, if I want to do it using this change of base method, I'm just going to set up my change of base. So this one here is equal to log of 1024 divided by log 4. And that I'm going to type in on my calculator. So again, here's our log button, log 1024. Don't forget to close bracket, divided by log of 4. And that's going to also get us to 5 there. So you have 2 different ways to do this. Whichever method you prefer, you can use it. I'm just going to use my graphing calculator for the majority of these, as that's what is being asked. So in the next example here, in example 2, I have this here, log base 2 of 1024 divided by log base 2 of 4. So here I'm going to go log base 2 of 1024. That's going to be divided by log base 2 log base 2 of 4. And here our answer, just 5 again. Over here in example C, we have, again, all of this is going to be on my graphing calculator now, just to get familiar with it. Log base 9 of 27 is equal to 1.5. So here we have an answer of 1.5. And again, of course, if you couldn't remember where your log base button is, just use your log button. So it's going to be log 27 divided by log 9. And you should have net the same answer, 1.5, both ways. For the last one here, we have log base 32 of 1/8, and this one here is going to be equal to log base 32 of 1/8, and again 1 divided by 8 is what I'm typing in. Here we got negative 0.6, which I'm going to convert over to a fraction. There we go, we got negative 3.5. And usually I leave my answer as a fraction rather as a decimal, but be aware for multiple choice, take a look for both answers. In example number 6 here, we're going to try to solve for x. So again, how can you solve this? So either one, if you know where x is, you could type it into your calculator, or two, you can solve it long-handed. So here, I know that if I'm just looking for the answer, I can just type it in. So this is going to be log base 3 of 243. That's going to get me x equals 5. So here, x is going to equal 5, and that was straight off of our calculator. If you wanted to do it the long way, we could do 3 exponent x equals 243, and then you'd have to do change of base, and of course 243 is, and of course, yeah, sorry, 243 is, and I'm going to just show my change of base, there's my x, is equal to base 3 of 5, so x has to equal 5 anyways, and so that's how you do it the long way. But this is right off of your graphing calculator. This one here, kind of tough to type into your graphing calculator, you really can't type it, so let's quickly do a rewrite on this. So this is now x exponent 3 equals 1 over 64, and you want to get x there by itself. How do you do that? Well, I'm going to cube root both sides, cube root here, cube root on this side here, so x is ending up being 1 over 4. Over here we have, just to rewrite it, we're going to go 36 to the exponent of 3/2, and that's going to equal us to x. So x here, just simply solving that there, so the square root of 36 cubed, so that's 6, and then cubing that is 216, so x equals 216. And there we have it. That's the end of our lesson. If you have any questions, please feel free to ask.